Thank you for your interest in helping the National Weather Service in Louisville by joining the ranks of our SkyWarn storm spotters. This training consists of 4 required modules. A short quiz will be administered after each module. Once you have completed all of the modules, you'll be able to register in the National Weather Service Louisville Spotter Database and receive a certificate of completion. This module will provide you with information about the types of severe weather warnings the National Weather Service issues. Other modules include how the weather works, a brief look at the how and why thunderstorms develop. Storm spotting, a guide to what cloud features to look for that indicate potential severe weather. And last but not least, information exchange, where we'll discuss how you can get information you need to keep yourself and your loved ones safe, and how you can help others by relaying your observations to the National Weather Service in Louisville. Additional supplemental modules will be made available in the future, and you are encouraged to take as many of those as you'd like. Module 1, the basics of severe weather warnings. In this module, we'll focus on key weather definitions used by the National Weather Service and provide a brief overview of the severe weather warning process. Thunderstorms are always taking place somewhere on Earth at any given moment in time. These storms are a necessary and valuable source of fresh water for our planet, but can sometimes become violent and threaten the lives and property of people in their paths. As part of their core mission of protecting lives and property, the National Weather Service issues severe thunderstorm warnings when a storm intensifies to the point that it meets one or more of 2 measurable criteria. Which of these thunderstorm elements are the 2 the National Weather Service uses to define a severe thunderstorm? Lightning occurs with every thunderstorm. It's lightning that creates the thunder. For that reason, it is not one of the criteria used to identify the most dangerous storms. However, because lightning can kill, whenever you hear thunder, you should always move inside a sturdy shelter and avoid contact with any conductors of electricity, like metals and water. On its own, even heavy rain is not considered severe. One caveat though, if enough rain occurs, heavy rain can cause flooding or flash flooding, which is a severe event covered by its own warning. Hail is a measurable criteria that the National Weather Service uses to define a severe thunderstorm. Once hail reaches 1 inch in diameter, about the size of a quarter, it is capable of damaging roofs and denting automobiles. Larger hail is even more dangerous. Thunderstorm winds in excess of 58 miles per hour are capable of damage to sturdy structures and healthy trees, which in turn can produce airborne debris that could injure or even kill you. For this reason, the National Weather Service issues severe thunderstorm warnings for storms that produce winds of this velocity. Severe thunderstorm warnings are issued when storms are expected to produce either 1 inch hail or 58 miles per hour wind, or both. Because instruments to measure wind speed are only in a limited number of locations, it is often necessary to estimate wind speed based on the observed effects of the wind. The Beaufort scale is a good guide for doing this. The National Weather Service issues severe thunderstorm warnings for winds that are strong enough to cause structural damage, but we also issue special weather statements for lesser winds that might knock down twigs and branches or pose a hazard with outdoor tents or awnings. Hail reports have the most value to the National Weather Service when the hail size is reported in relation to a known object. Marbles come in many different sizes, so it's much clearer to everyone if you can use coins, penny, nickel, quarter, $half as a reference size when making reports, or the size of common sports balls when larger. While large hail sizes are obviously important to report, any hail larger than a diamond size should be reported, along with the location it occurred, as this can help meteorologists correlate hail size to radar intensity of storms occurring that day. Believe it or not, all tornadoes are invisible. A tornado is a violently rotating column of air, and air is invisible. What makes most tornadoes visible is one of 2 things: First, a condensation cloud that can occur when water vapor rises and cools rapidly in the tornado. Or, two, a dirt and a debris cloud resulting from a tornado causing damage on the ground. At times, a funnel cloud may be seen extending from a parent thunderstorm, but not in contact with the ground. In this case, you should look for signs of rotation on the ground below the funnel. If there is rotation on the ground, then there is a connection, albeit invisible, with the rotation in the clouds, and that is a tornado. Conversely, sometimes funnel-shaped clouds descend toward the ground but are not rotating. If a cloud touches the ground but it does not rotate, it is not a tornado. A cloud on the ground does have a name, though. It's called fog. Just as with snowflakes, no two tornadoes are exactly alike. However, we can classify twisters into two distinct categories. The first category are supercell tornadoes. Supercell tornadoes, like the one that hit Henryville on March 2nd of 2012, are fairly clear-cut. Almost all of the violent, long-track tornadoes come from supercells, but supercells can produce weak tornadoes as well. Non-supercell tornadoes are the second category. Among these are waterspouts, which occur frequently over the warm waters of the Gulf of Mexico, and their high plains cousins, landspouts, which occur most frequently in eastern Colorado and nearby areas of the high plains just east of the Rocky Mountains. In the central Ohio Valley, the most common tornadoes that occur happen in association with fast-moving squall lines, which tend to be short-lived, usually weaker, and more difficult to warn for than those coming from supercells. However, not all of these are weak. A few have produced winds as high as 130 miles per hour. Lastly, storms that produce an intense downdraft occasionally generate a tornado-like vertical rotation known as a gustnado. While these can reach the intensity of a weak tornado, the key difference between these rapid spin-ups and a true tornado is that they are not connected to any rotation within the parent thunderstorm. Because of this, they usually last less than a minute. This photo, taken by a Western Kentucky University meteorology professor, shows a gustnado that occurred south of the Bowling Green campus in 2011. Tornadoes are classified on a 6-point scale created by and named after Dr. Theodore Fujita, a tornado research pioneer at the University of Chicago. This scale estimates a tornado's peak winds based on the destruction that occurs with the twister. In 2007, the original Fujita scale was modified to account for variability in the quality of building construction and to incorporate empirical research in the wind speeds needed to cause observed damage. The enhanced Fujita scale ranks tornadoes from a minimum of EF0 with winds of 65 to 85 miles per hour to a maximum of EF5 with winds in excess of 200 miles per hour. As can be seen in this pie chart, the vast majority of tornadoes fall into the weak category, EF0 and EF1, with wind speeds less than 110 miles per hour. Less common are the EF2 and EF3 strong tornadoes, with winds up to 165 miles per hour. At the top of the scale, the violent EF4s and EF5s are extremely rare, accounting for just a small fraction of all known tornadoes. Keep in mind that even weak tornadoes are dangerous and can kill, especially if you're not in a sturdy shelter. In 2013, in large part because of the differences in type and intensity of tornadoes, the National Weather Service began including enhanced wording in tornado warnings to better convey the severity of the threat with each warning issuance. The new information shows up by way of hazard, source, and impact statements in the body of the warning, and with the addition of the tornado and tornado damage threat tags at the end of the warning. For severe thunderstorm warnings, a tornado possible tag may be included if the severe thunderstorm has some potential for producing a tornado, but the signature is not strong enough for forecasters to issue a tornado warning. These tags are designed to communicate hazard and risk information only. They are not intended to identify tornado intensity in relationship to the EF scale. Like tornadoes, not all floods are the same, but all are dangerous. When heavy rains occur over a period of days or weeks, rivers of all sizes can rise out of their banks. River flooding and damage can be widespread and last for days or weeks on end. Very heavy rain over a short duration can cause flooding in poorly drained areas, especially those with a lot of pavement to keep water from being absorbed into the soil. Aerial flooding tends to be quite localized and typically lasts anywhere from a few hours to a day or two. This security video from the University of Louisville shows the effects of more than 7 inches of rain falling in only 3 hours in an urban setting. While the water is not flowing rapidly here, it is still dangerous for a number of reasons. Floodwaters can contain a number of toxins, gasoline and oil from road surfaces, fertilizers from yards, raw sewage, and other chemicals you would never want to swim in. Another hidden danger in urban flooding is manhole covers that pop off of storm sewers as rainwater overloads the drainage system. And keep in mind that damage to vehicles that stall in deep water can range from needing their interiors replaced to completely ruining the engine and electrical wiring. Flash flooding is typically the most deadly of all flooding because of its quick onset. It's marked by rapidly rising, swiftly moving water that can wash away roads and vehicles, sometimes in locations that have no running creeks or streams. In any given year, flooding, and especially flash flooding, is among the top 2 thunderstorm-related killers in the Ohio Valley and the nation. Most of these fatalities occur in automobiles when people drive from a place of safety into running water, as shown in this video. These are the most preventable of all severe weather fatalities. Remember, turn around, don't drown. It can be that simple.
Eddie, call 911, hurry! Call 911!
In a typical year, more people in Kentucky are killed by flooding than any other thunderstorm-related phenomenon. Note that more than half of the tornado fatalities in Kentucky since 1995 occurred with the March 2, 2012 outbreak. In Indiana, tornadoes have claimed a greater number of lives since 1995 than any other weather phenomenon, but floods and flash floods are a more frequent threat. The warning process is a 3-tiered approach. First, the goal of the National Weather Service is to provide a heads-up to the potential for severe weather from 1 to 3 days in advance. This is done in the form of both graphical and text products known as outlooks, which highlight in relatively broad terms the area where meteorologists are focusing on the potential for severe weather and which type might occur. Then, several hours before severe weather, a watch tells people to be alert to the upcoming potential for dangerous storms. These are issued by the Storm Prediction Center in Norman, Oklahoma, in consultation with local National Weather Service offices. Finally, a warning tells you that severe weather is imminent and immediate action is needed. Most warnings are issued based upon radar, but occasionally a spotter's report can trigger a warning if none is in effect. Here's how the outlook from the Storm Prediction Center evolved in the days prior to March 2, 2012. The risk for severe storms in the Ohio Valley was identified 3 days ahead of time. As the event drew closer, the outlook was upgraded to a high risk and fine-tuned as it became more certain that Kentucky, Indiana, and Ohio would see large and deadly tornadoes. At the local National Weather Service office level, the hazardous weather outlook, issued at least twice each day, focuses on the threats expected over the next week for its area of responsibility. In this example, the National Weather Service office in Jackson highlighted that tornadoes were possible 36 hours before they occurred. Considering that tornadoes are relatively rare in the hills and mountains of eastern Kentucky, this was not something to be taken lightly. On the morning of March 2, 2012, meteorologists knew that the weather was shaping up to become a particularly dangerous situation. It doesn't take a major outbreak for notifications to go out, though. On any day when severe weather is expected, the Storm Prediction Center, or SPC, will issue a severe thunderstorm or tornado watch. The SPC strives to issue these long-fused watches 1 to 2 hours before conditions are favorable for dangerous storms to develop or move into an area, giving residents of the area as much time as possible to ready themselves for the threat. When issued, severe thunderstorm and tornado watches usually last for 4 to 6 hours and cover an area roughly the size of a state. Flood and flash flood watches, however, are issued by local National Weather Service offices, as the forecasters in these locations have greater knowledge of local terrain and geology, which plays a large role in flooding. Local National Weather Service offices issue a warning to indicate that immediate action is required to protect lives and property. These warnings can be issued based on a radar signature or a reliable report, so this is one way your timely ground truth report can have an impact. Severe thunderstorm and tornado warnings are storm specific, issued for the thunderstorm believed to be severe and for the area this storm will move over, typically in the next 30 to 45 minutes. These are considered short-fused warnings because they go into effect the moment the meteorologist transmits them. While most convective warnings last less than an hour, the exception is the flash flood warning, which can last as much as 6 hours, depending on the ongoing rainfall. Severe thunderstorm, tornado, and flash flood warnings are issued by local National Weather Service offices. In central Kentucky and southern Indiana, these warnings come from the National Weather Service office in Louisville. Other offices serve the remainder of Kentucky and Indiana. Unlike trains, planes, and automobiles, storms don't move along predefined paths like railroad tracks, highways, and air routes. Because of this, severe thunderstorm and tornado warnings may cut across a county or multiple counties in different directions from one day to the next. For that reason, visual graphics of the warned area available from a variety of sources, television, online, or via smartphone, are important supplements to an audible warning received via NOAA weather radio, commercial broadcast radio, sirens, or reverse 911 phone calls. It must be reiterated that in most cases, severe thunderstorm and tornado warnings are based on information obtained by radar, with the goal being that a warning be issued before a storm becomes severe at the Earth's surface. Unfortunately, While radar tells us much about what is happening several thousand feet above ground inside a storm, there are many things that can happen in the very lowest levels of the atmosphere below the lowest radar beam that can keep a storm from producing the type of severe weather expected on the ground. This image is an excellent example of that. The shaded boxes show all of the tornado warnings issued in Kentucky on March 2, 2012. The thick lines represent the tornadoes that touched down that day. At first glance, it appears as though the National Weather Service was overwarning that day. With respect to tornadoes, that turned out to be the case. For reasons not fully understood at the time, the supercells that produced the killer tornadoes over parts of the Ohio Valley that day passed over many locations without dropping a tornado. However, this does not mean those storms were not severe. What is not displayed on this map are the hundreds of large hail and damaging wind reports that accompanied those storms for hours before they became tornadic. The bottom line with any severe weather warning is this: warnings are issued for storms that are either already producing severe weather or have the capability to do so immediately. Let's go over some of the key information covered in this module. To be considered severe by the National Weather Service, storms must produce at least one of the following: winds of at least 50 knots or 58 miles per hour, and or hail at least 1 inch in diameter. Tornadoes are violently rotating columns of air extending from the base of a thunderstorm and in contact with the ground. Not all tornadoes are visible, and a funnel-shaped cloud may indicate a tornado, but if there is no rotation associated with the funnel, it is not dangerous. Even if a storm does not meet severe criteria, it can be dangerous due to lightning, which occurs with every thunderstorm, and heavy rains that can cause flash flooding. Severe thunderstorm and tornado watches mean conditions are favorable for severe weather. Watches are issued by the Storm Prediction Center. Warnings mean severe weather is imminent or occurring, and that you should take cover immediately. Warnings are issued by the local National Weather Service offices. Congratulations! You have completed Module 1 of the Basic SkyWarn training course. You may now proceed to a brief quiz to test your knowledge of the information presented here.